Okay, well, welcome back. We're going to be talking about decay this time. So we talked about growth, exponential growth, and we talked about how that affects money. We're going to talk about exponential decay this time. So an exponential decay function is one that decreases as we move left to right across the x-axis. So what's going to happen is you're going to start up on the graph and you're going to curve down through the graph. The decay factor is when your b is a fraction. So it's less than 1 but bigger than 0. That's a decay. So again, we go back to this function y equals, and again that got kind of messed up in my translation here, a b raised to x. Okay, so when we have this function here, when we get something, for an example, let's say 2 times 1/2 raised to x, this is your decay factor, that 1/2. So because that goes down now, you're going to have a function that's going to travel this way, and it's going to be a decay model. So it's just going to roll across the graph that way. But that's what a decay is. Now we use this in radiation, radioactive decay. Chernobyl was one of the, where a nuclear bomb went off. So as they said, they had that nuclear reaction. Over time, eventually that radiation is going to decay enough to where people can go back and be around that area. If not, then it's not going to be livable. But it's actually going to decay as it goes through. Okay, so let's look at problem number 3. The kilopascals is a unit of measure for atmospheric pressure. The atmospheric pressure at sea level is about 101 kilopascals for every 1,000 meters of increase in altitude. The pressure decreases about 11.5%. What is the approximate pressure of the altitude of 3,000 meters? Okay, so we're going to go ahead, let's write down our formula. A, b raised to x. We got to figure this stuff out. Now they gave us at sea level. If you don't know, sea level is 0. That's what we use for height. Sea level will be 0. They already told us that's 101. So because they told us sea level is 101, we know A, because A again is our initial amount. So we're down to y equals 101 b raised to x. But then they told us it decreases 11.5%. So if I take 100% and take away 11.5, I get 88.5%. That's what we're talking about. That's what it's increasing each time. It's only getting 80% of the previous. So that's actually our b as a decimal. So we got to put 0.885. That is actually our b. So they did give us a lot of information in this particular problem. It said y equals 101.885 raised to x. Now they said for every 1,000 meters increase, that's what the pressure drops. So we're going 3,000. That's 3 times that. So what we want to know is 101 times 0.885, and then we want to put 3 in that location. So we go to our calculators, we take 0.885 raised to the 3rd power. We're going to multiply that by 101, and we should get 70 as our answer there, which is in kilopascals. Okay, that's 70 units that our pressure is decreasing there. Okay, so what would be the atmospheric pressure at the altitude of 5,000? So using that previous problem, go ahead and do got it number 3. Figure out what that 5,000 mark would produce. Okay, so there's our answers to example 2, example 4, and got it number 3 that we've done through the sections. That's it for this whole section. So we broke that up into smaller pieces. Hopefully that was easier for you to kind of work through little piece by little piece. If you have any questions, again, discussion board, or hit it up on Twitter. Just let me know in class if you still don't have answers to your questions. Have a good night.